Problem number 72. What is the mass in grams of each quantity of vitamin D? It gives you the molar mass of vitamin D, and it tells you it's needed for forming and maintaining healthy bones. So we're given 4 quantities of vitamin D. These two are a certain number of moles, and those two are a certain number of molecules. So how about let's do B and C. So how many grams is 0.58 moles? Now, using the molar mass, we know that it's 384.7 grams per mole, and that means that 1 mole of vitamin D is the same thing as 384.7 grams. And this allows us to convert from moles to grams. So starting off with 0.58 moles, we use the relation above to make a conversion factor, get rid of moles. 1 mole goes on the bottom, 384.7 grams on top, and the mole units cancel. And the calculator, let's see what it gives us. 0.58 times 384.7 and get 223.126. 223.126 grams. Now we start with 2 sig figs. The molar mass is 4, so we're going to be limited to 2. We're going to have to round here. It's going to round to 220 grams. And there you go. So for B, we are dealing with a certain number of molecules. I did B. I'm sorry. We're going to do C. So that was B. Now for C. So how many grams is 7.3 times 10 to the 24 molecules? Okay, and if we convert molecules to moles, we can use the molar mass to get to grams. So how do you go from molecules to moles? Well, as always, 1 mole of a substance is the same thing as Avogadro's number of particles. And the particles this time are the molecules. So we can go from molecules to moles, and then from moles to grams. This will be a 2-step conversion. 1, 2. Let's put them together. So we're getting rid of molecules, so we put Avogadro's number down here, 6.022 times 10 to the 23rd molecules, and then that's 1 mole. And then we know that 1 mole is 384.7 grams. So you see how the first conversion factor gets rid of the molecule units, and the second one gets rid of the mole units, and we're going to be left with grams. So we'll put our answer down here and punch in to the calculator. If you're not sure, again, just use parentheses. 7.3 times 10 to the 24. So you see that this number right here of molecules, that's bigger than Avogadro's number. So we have more than a mole. We should expect that we're going to have more than 384.7 grams, because we're starting with more than a mole of molecules. So let's just see. Okay, so we take that, we divide it by, let's parenthesize Avogadro's number, 6.022 times 10 to the 23rd, and then we're going to multiply that by 384.7, and there you go. The answer comes out to 4663.4174. 46 663.4174 grams. And we're limited to 2 sig figs again because of the starting quantity. So that'll round right there. And using the rules for rounding, we're going to get 4,700 grams. Check.